Hello, everyone. Today we are looking at Chapter 8, Aquatic Biodiversity. Okay. And then this one is a part of Chapter 2 to 8, and then we are still at the Science Ecological Principles and Sustainability, the basic materials. Okay, and then for this section, we're going to look at a core case study, which is a coral reef. And then we look at the general nature of all aquatic systems. Then we divide into two sections. One is marine aquatic systems, and then freshwater systems. Okay, so this slide probably only covered the case study and then the general water aquatic system nature. So this one is the beautiful coral reefs. And then what are coral reefs? Coral reefs are among the world's oldest, most diverse, and most productive ecosystems. And a coral reef forms when massive colonies of tiny animals called polyps die, leaving their empty crusts behind as a part of a platform for more reef growth in clear, warm coastal waters of the tropics and subtropics. So the resulting elaborate network of crevices, ledges, and holes serves as a calcium carbonate condominiums for the variety of marine animals. And then one of the assignment in your Chapter 8 review question is, what are the 5 major characteristics of coral reefs? So they are, number 1, mostly form in clear, warm coastal waters in tropical areas. Second, they are among the world's oldest, most diverse, and most productive ecosystems. Pretty much they are equivalent to the tropical rainforest on land. Number third one, they are formed by massive colonies of tiny animals called polyps. Polyps are relatives of jellyfish. Number 4, coral reef slowly build reefs by secreting calcium carbonate. This is the major component in limestone around their soft bodies. And then lastly, corals polyps have a mutually beneficial relationship. This is symbiosis with a tiny single cell algae live inside of them. They are called zooxanthellae. So polyps and this single cell algae zooxanthellae live together. So coral reef provide important ecological and economic services. However, they are vulnerable to damage. Warmer ocean temperatures leading to coral bleaching. What do you mean coral bleaching? We would have another slide. But basically this one means the disappearing of its color. And then the color of a coral reef is caused by the algae live inside of them. And then, so basically the warmer ocean temperature kills algae. And then if the algae is gone, the polyps will die out too. Another way to cause the damage is increasing ocean acidity, because we have so much carbon dioxide. When carbon dioxide dissolves in water, they make the water more acidic. Nothing to mention, we have acid rain too. Okay, so the increased acidity dissolve coral skeleton, calcium carbonate, and other shellfish. Their shell is made of calcium carbonate too, so they also get dissolved. So let's look at some ecological services of coral reefs. Oh, wait a second. Thank you. They help, they help moderate atmospheric temperatures by removing CO2 from the atmosphere. through the photosynthetic activity of the algae living in them. And also they act as natural barriers that protect 15% of the world's coastal lines from erosion caused by battering waves and storms, because they live on the seashore, so they can buffer the waves, the erosion. They also provide habitats for 1/4 of all the marine organisms. So basically, if we destroy the coral reefs, so 1/4 of the marine organisms, they would homeless, they will eventually die. And then coral reefs also provide economic services. Remember, economic services means to our human society, okay? Coral reefs produce about 1/10 of the global fish catch in general. But if you're looking at developing countries, this is about 1/4 of their fish catch from coral reefs. And the coral reefs also provide jobs for tourism. They provide building materials for some of the world's poorest countries, because they can get this one used as like a brick, like a concrete to build a house. Finally, these biological treasures give us an underwater world to study and to enjoy. Each year, more than 1 million scuba divers and snorkelers visit coral reefs to experience these wonders of aquatic biodiversity. I hope you guys have had those experiences, or you will have those experiences. So again, one concept of coral bleaching is very important. You need to know this one. Coral bleaching occurs when stresses, such as increased temperature, cause the algae living in coral to die off, leaving behind a white skeleton of calcium carbonate, because calcium carbonate itself has no color. So algae in coral give different colors to the corals they live with. Upon the algae, corals depends on food. So when the algae dies, they will die soon. Okay, so this one is a picture to show you the bleaching of coral reef. You can see once the algae die off and then the color show off is the calcium carbonate. And then soon the coral, because they rely on food from algae, they also will die. Let's look at the major threats to coral reefs. So the major threats including climate change and ocean acidification. So mainly we can summarize into two: climate change and ocean acidification. Both have a lot to do with human activities, such as burning fossil fuels and deforestation, leading to global warming. So the sad news, and this number you need to remember, is by 2050, it is estimated that more than 50% of all coral reefs will be lost. That would be a big tragedy. So now we look at section 1. What is the general nature of aquatic systems? The first concept: saltwater and freshwater aquatic biozones, bioareas, cover almost 3/4 of the Earth's surface, with the oceans dominating the planet. So imagine those pictures. 3/4 of the Earth is covered by biotic life zones. The second concept: so within those life zones, key factors determine biodiversity in aquatic system. Not everywhere have the same amount of biodiversity. So the biodiversity determined by temperature, dissolved oxygen in water, availability of food, and access to light and nutrients necessary for photosynthesis. And lastly, depend on salinity. I underline this word. This means how much salt in water, because sometimes this idea, this factor, ignored by us, salinity. Most of the Earth is covered with water. So salt water is about 71% of the Earth's surface. And then if you look at the ocean, the 4 major areas, they are called Atlantic, Pacific, Arctic, and India. So I have been to Atlantic, Pacific, but not to Arctic India. How about you guys? And then sometimes the Southern Sea, people call the fifth one. And then freshwater overall, the rivers and streams cover about 2% of the Earth's surface. And then the aquatic equivalents of biomes are called aquatic life zones. An aquatic life zone is a biome in water area in the hydrological sphere. Okay. So aquatic life zones. So you can divide into two. One is saltwater life zones, like marine life zones. So these are oceans and estuaries, coastal lands, and shorelines, coral reefs, mangrove forests. And then for the freshwater life zone, just normally lakes, rivers, streams, inland wetlands, and also ponds. Right, the other day we're looking for pond. Okay, and then also the living organisms in aquatic biozone, based on how how active they are or where they live, we give them different names. You need to know those names. Okay, one is phytoplankton. So those are primary producers. Okay, in general, plankton are just the drifting organisms. So they are in water, but they are not active swimmer. So basically they drift together with the tide, with the current. Okay. So among plankton, one is a phytoplankton. So those are the primary producers of most aquatic food webs. And then algae things. Okay. And then you have ultraplankton. Those are extremely small photosynthetic bacteria that may be responsible for 70% of the primary productivity near the ocean surface. So bacteria, photosynthetic bacteria are important. And then zooplankton. They are herbivores. So they can be carnivores too, but those are consumers. They eat algae or they eat one another. So they are single-celled to large invertebrate like jellyfish. And then for those living organisms in water, they move really fast. We call them nekton. And then these are fish, turtles, whales. All of them, they can swim against the current. And then also you see organisms living at the bottom, stay there, no moving or crawling around or attached to something. We call them benthos, such as oysters, sea stars, clams, lobsters, crabs, barnacles. Okay. And then another one is decomposers. They can be everywhere. So mostly they are bacteria. Again, this one is a repeat slide. Key factors in the distribution of organisms. Temperature would limit them, dissolved oxygen, availability of food, availability of light and nutrient, and then salinity. And then one more is turbidity, which is the degree of cloudiness in water occurring naturally and human activity. So this one would inhibit photosynthesis. If you watch this video after our water testing, you know what turbidity is. Okay. Now we're going to quickly look a little bit at the marine aquatic system. So the concept is seawater ecosystems provide major ecosystem and economic services. And then they are irreplaceable reservoirs of biodiversity, meaning nowhere, any place can replace the biodiversity they hold onto it. Okay. And then sometimes we would praise people how much money they earn, but look at the ocean. So we estimate it's yearly the money the ocean can earn, the seawater can earn is $1 trillion per year. We really should respect nature, respect the environment. And then there are 3 major life zones. They are coastal zone, the open sea, and then ocean bottom. We will get into more details for the part 2 of the video. Thank you for watching this one.